All right, so last time we said that sharing of electrons is a covalent bond. However, as you may know, sharing of electrons is not always equal. Electrons and bonds are not always equally shared. So say sharing, not always equal. And so what determines how this is going to be shared? Well, that depends on the electronegativity of an atom. And sometimes it gets the symbol capital EN for electronegativity. And electronegativity is a measure of how much an atom pulls on shared electrons. So the more electronegative an atom is, the more it's going to pull on those electrons, and the more time that electron is going to spend on that particular atom versus the other atom. So if we draw our periodic table, we remember that electronegativity has a trend, and this is one of the most important trends that you really want to know. You really want to be comfortable and familiar with electronegativity. So remember, we ignore noble gases because they generally don't form bonds. And then when we go from left to right and from down to up, electronegativity increases. So the top right is the most electronegative, and the bottom left is the least electronegative. So if we look at our periodic table, we'll see fluorine is on the top right, and so this is the most electronegative element there is. Fluorine is the most electronegative. And then down here in this bottom left, we have cesium. So cesium is the least electronegative. And so here's just a picture of this, which kind of gives you some more defined numbers. You don't have to know these numbers, but you just want to kind of know the trend and be able to identify which atom is more electronegative than another. So you can see, as we've indicated previously, fluorine is the most electronegative, and then cesium is the least. And then as we go towards the top right, we get more and more electronegative. Another thing to note is that oxygen is more electronegative than chlorine. Even though it's only one step away, oxygen is more electronegative. So electronegativity decreases faster going down than it does going left. And you can see this again with nitrogen being more electronegative than bromine, right? Both 2 spots away, but nitrogen is more electronegative. And so the type of covalent bond we're going to have here is depending on the difference in electronegativity. So for example, if we have H2, we have 2 of the same atoms. So they have the same electronegativity, so they're pulling on the electron the same amount. And so they're equally sharing this electron, right? So if we drew this little kind of circle as our kind of electron cloud, where our electron is spending its time, we'll say that this is non-polar, right? Non-polar. There's equal sharing of electrons. However, if we take a look at a different scenario, like an HCl bond, right? If we take a look at these two, chlorine is significantly more electronegative than hydrogen. So they're going to have unequal sharing of electron. The chlorine is pulling on the electrons more, so the electrons are going to spend more time around the chlorine. So when we draw a little electron cloud, we draw it bigger on the chlorine side. We can also indicate this with the partial charges. So this side is a partial positive. Remember, this delta symbol means partial. So the hydrogen is partially positive and the chlorine is partially negative because the electrons are spending more time on the chlorine. Another way to show this is with a dipole arrow. So remember, in a dipole arrow, the partial positive end gets the positive end of the arrow, and then the negative end gets the arrowhead. And so we say this bond is polar. Another good thing to do is just Google compounds and then just include electrostatic potential. And so what you'll see is these kinds of maps show up. And so the color here is indicating where the electron is spending most of its time. And so you can see the same as our example, right? In H2, the electron is equally shared between the two hydrogens, whereas in HF, the electron is spending significantly more time on the fluorine. And so this one has a dipole and is polar, while the other one is not.